In this video, we're going to talk about how to categorize and describe sets. So there's 4 different ways that I'm going to talk about that we can categorize and describe sets. And the first one is whether or not the set is empty or null. And so a set with no elements is called an empty set or null set. So those mean the same thing. And it's denoted by either a curly bracket with nothing in it or a empty set symbol, which is the circle and the line through it. So there's nothing inside the curly brackets or the empty set symbol. And so let's go through examples A through D and talk about whether or not these sets are empty. So A, the set of woolly mammoth fossils in museums. So ask yourself, are there woolly mammoth fossils in museums? If so, the set is not empty. And I would say, yeah, there are museums that have woolly mammoth fossils. So I would say this is not empty, this set. For B, all values of x such that x is a living woolly mammoth. Well, there aren't any living woolly mammoths, so this would be considered an empty set. For part C, I have those brackets with nothing inside it. So because it's empty, that means it's an empty set. Now this last one, this is the trickiest of all because you might look at this and say, oh, well, I see this empty set symbol. I think this is an empty set. This one is actually not an empty set because you see these curly brackets. It has the empty set inside. So the empty set is inside another set. So it's technically considered not empty. I know it's kind of weird to think of it like that, but hopefully with some time you'll get used to it. So you just got to look at the notation, and if you see anything, even if it's the empty set symbol inside of curly brackets, at that point you say it's not empty since that empty set is inside. As opposed to if I just see the empty set symbol, then you say empty. If I just say, or if you just see the curly brackets, you say empty. But when you see them together, that's when you say not empty. Okay, so let's look at the second way that we're going to talk about describing sets, and that's whether or not they're finite or infinite. So if a set is a specific number of elements, like you could count them, then it is called finite. A set that is not finite or goes on forever is what we call an infinite set. And really, with infinite sets, you just want to look for the ... which is called an ellipsis. So let's look at these examples. So is the set P, Q, R, S, T, U, V finite or infinite? Why? Well, I would say finite because there are 1, 2, 3, 4, 5, 6, 7 elements. I can count them. It doesn't go on forever. Is the set 10, 20, 30, ... finite or infinite? I would say infinite because it goes on forever and there's no end. So I would say look for ... and no end. Sometimes the ... or the ellipsis can be used in a finite set. I'll just give you an example of that real quick. So maybe you have the set 2, 4, 6, 8, 10, ... I'll put a comma there, all the way up to 20. So maybe this is the set of even numbers between or from 20 ending at, or from 2 ending at 20. The ... just fills in the middle. So because there's that ending number, I would say this is finite. But up here, there's no ending number. So there's no ending number. Don't need a comma there. No ending number. So we're going to say it's infinite. Goes on forever. And then is the set empty set finite or infinite? Well, I think you have to go and look at the definition if you're not sure. So if it has a specific number of elements or no elements, so notice that right there, then it's considered finite. So by definition, the empty set has no elements. So we're going to say finite because it has no elements. And the definition says that that's considered finite. The third way that we're going to talk about how to describe a set would be to look at the number of elements in a set. So, and that's called the cardinal number. So the cardinal number of a finite set, we'll call this set A, it could be any set, is the number of elements in A. So cardinal number just means the number of elements in A, and it's denoted with a lowercase n parenthesis and then whatever the set name is. So in this case, this definition, we're using set A, so I'm putting an uppercase A. That's going to change depending on the set name. So for example, we have 3 examples, sets A, B, and C. So this first one, I could say n of A, which just means number of elements in A is 1, 2, 3, 4, 5. Because there's 5 elements. Or the second one, n of B, means the number of elements in B. Now this one's a little bit trickier because you have the dot, dot, dot. And so we have, and if you want, you could fill it all out. So 10, 11, 12, all the way up to 20, 13, 14, 15, 16, 17, 18, 19, 20, and then you could count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we say n of B is 11. And then this last set C, we say n of C equals, and it looks like they're even numbers starting at 2, ending at 500. So if we think about what this would look like if we started at 1 and went to 500, we would say, okay, there's 500 elements if we had every single number, but we don't, and so we could cut that in half. And so instead of 500 elements, there are 250 elements. Now note that if this had started with 0, there would actually be 251 elements. So now the last thing we're going to talk about, last way that we can describe sets would be to say if they're equal or equivalent. And so if you have 2 sets, so we're talking about comparing 2 sets, if they have the exact same elements, they're considered equal. And we use the equal sign to show that they're equal. And then if you have 2 sets that have the same number of elements, so the elements themselves don't have to be the same, but they could, then they're considered equivalent. So let's look at some examples. So in this example, we have 2 sets and they both have 4 elements, but the elements are different. So we would say these are equivalent. In this example, we've got a set with 213. So this has 1 element, 213. This one, this is tricky. At first glance, you might think, oh, they're the same, 213, but this has 3 elements, 2, and then 1 and 3. So this has 3 elements. These are not the same. So I'm just going to say neither equal or equivalent. And then lastly, we have set builder notation. So all values of x such that x is E, so remember what E means. So E stands for even natural numbers, and the number has to be less than 10. So let me list that out. So I'm going to just list out the even natural numbers where x is less than 10. So that would be 2, 4, 6, and then 8, because E would be 2, 4, 6, 8. Those go on forever and ever, but I only want the even numbers, even natural numbers that are less than 10. So I just look at the 2, 4, 6, 8. So that's what that set builder notation is describing. And then I'm comparing it to 2, 4, 6, 8. Well, those are the same sets. So I would say these are equal.